Hi there, this is Callie, here to tell you about Virtel Web Access. How secure is it? Let's start by reviewing the design principles that serve as a foundation to our web access security. We firmly believe that the simple centralized infrastructure of Virtel Web Access, which relies on 100% standard web technology, is easier to protect than the decentralized infrastructure and SNA over IP connections that TN3270 emulators rely upon. We rely exclusively on standard web technology for the web connection and web client. That is, end-to-end encrypted HTTP connections as opposed to TN3270 connections, and using the web browser as the client as opposed to Java client applets. We keep the control of access to host assets on the host where it belongs, whereas TN3270 emulators rely on distributed Java client applets, which result in distributed security exposures, which results in the host losing control of access to its own assets. We also believe that with web-originated accesses, user authentication has become very critical. Are you really who you say you are? Single-factor authentication, such as the RACF user ID and password, is no longer sufficient. Multi-factor authentication, such as that provided by SSO systems, is becoming a must. Nobody has the resources of IBM, Google, or Apple, and other top software publishers when it comes to security investments. So we believe that the smartest thing to do is to leverage the security investments made by those top dogs whenever possible. For example, we leverage IBM's ZOS Statement of Integrity by keeping as much of the web access solution as possible inside the host, where it gets the best possible protection. We also leverage IBM's ATTLS and ICSF for the SSL encryption of HTTPS connections. By relying on web browsers instead of client applets, we leverage the huge investments that Google, Microsoft, Apple, and Mozilla are making to improve the security of their web browsers. And by positioning ourselves as an integration component between host applications, host security system, end users, and multi-factor authentication products, we leverage the innovative solutions that come from the SSO marketplace. Now, onto more novel territory. We believe that ultra-thin translates directly into ultra-secure, and that the key to a truly secure web access includes virtual device infrastructure and cloud technologies. From a security point of view, ideally, 3270 clients should be ultra-thin with only the OS, a web browser, and whitelisted applications. Desktop applications should be provided as cloud services, such as Microsoft's Office Online, Google's G Suite for the cloud, and Apple's iWork on iCloud. And of course, 3270 application screens should be served as web pages to the client's web browsers, as we do with Virtel Web Access. We understand that not every organization is ready to go that far in streamlining their client workstations, but it is feasible, and I will later showcase a recent project where one of our Virtel customers replaced their TN3270 workstations with ultra-thin clients that access both desktop and 3270 applications in the cloud via the web browser. Now on to an even more novel concept. From a security point of view, we believe in strict client device management using a mobile device management product. This is the only way to ensure that your ultra-thin and ultra-secure clients remain ultra-thin and ultra-secure. So, you treat all 3270 client devices, including PC workstations, as mobile devices. Limit the software to OS, web browser, and whitelisted applications. Automate the software and security updates, and segregate corporate data, emails, and documents from personal ones. Those are the security design principles that we believe in. Throughout the rest of my presentation, I will highlight how Virtel Web Access adheres to those design principles. By the way, those red boxes to the left, there are stamps of approval. They will be used in the following slides to remind you of our key security design principles. When it comes to security, the strengths and weaknesses of a 3270 terminal emulation solution result directly from its architecture. Let's compare the architecture of Virtel Web Access to that of TN3270 emulators. TN3270 emulators rely on TN3270 connections and distributed client applets, typically Java client applets. Instead, Virtel Web Access relies on host-running middleware, end-to-end HTTPS connections, and client web browsers to which Virtel serves standard HTML JavaScript web pages. With Virtel Web Access, we keep the control of access to host assets on the host where it belongs. We rely exclusively on standard web technology outside the host, and the web browser is the client. We are now going to review the security features of TN3270 emulators and Virtel Web Access end-to-end, from the host to the client through the connection. Starting with the internet connection. TN3270 emulators rely on TN3270 connections. TN3270 connections do support SSL encryption, but not all TN3270 applets do, and even when they do, they may not be supporting the same SSL encryption level because it requires consistent TN3270 applet upgrades to support the same SSL encryption level. One of our prospects must support several SSL encryption levels because their users are on different levels of TN3270 applets. It is quite cumbersome and not very secure. In fact, most TN3270 emulation users have not deployed the TN3270 encryption. They rely instead on a VPN, which of course comes at an extra cost and with extra support requirements. With Virtel Web Access, it is much simpler because Virtel Web Access relies on end-to-end HTTPS connections. Those connections are SSL encrypted with ATTLS or ICSF, which, being IBM products, are always compliant with the latest FIPS level, today 140.02. Although Virtel can coexist with a VPN, it doesn't need a VPN to encrypt the data exchanged with terminal emulation users. In fact, some of our customers have simply dropped their VPN. Virtel also manages unique session and exchange identifiers. Although these identifiers are infrastructure components used to manage the sessions and exchanges, they also work as an embedded security feature because they allow detecting and rejecting man-in-the-middle attacks. If a message comes back from a client with an incorrect session and exchange identifier, Virtel immediately ends the session. So Virtel relies exclusively on standard web technology outside the host. It leverages IBM's ATTLS and ICSF encryption, and it keeps the control of access to host assets on the host where it belongs. Let's talk about the 3270 field attributes. As you know, 3270 applications assign one of the following attributes to each screen field. A hidden field shouldn't be displayed to anyone. A protected field can be displayed but not updated. An unprotected field can be displayed and updated. TN3270 emulators rely on their distributed client applets to enforce those attributes. They send hidden fields outside the host firewall all the way to the clients, and they don't check, upon return to the host, if protected fields have been changed. This is a security gap. It is known to hackers. It has been used to compromise host data. Virtel Web Access, which runs inside the host firewall where it is protected from web attacks, strictly enforces the 3270 field attributes. Virtel does not send hidden fields outside the host, and it checks if protected fields have been changed upon return to the host. If so, Virtel immediately ends the session. The control of access to host assets is kept on the host where it belongs. Now on to custom-defined data filtering. Same concept as the 3270 field attributes we just discussed, but with custom-defined data filtering. Client-based TN3270 emulators simply do not offer any custom data filtering capability. Through custom-defined scenarios and templates, Virtel Web Access enables administrators and security auditors to filter outgoing and incoming data flows. For example, outgoing data fields can be hidden, masked, or encrypted. Incoming data fields can be protected from update. This data filtering can be based on user credentials and authorization levels. It takes place on the host, behind the protection of the host firewall. Once again, the control of access to host assets is kept on the host, where it belongs. Now onto the mainframe authorization system, RACF, ACF2, or Top Secret. With TN3270 emulators, users are authenticated once at logon, and their authorization is not memorized. When an application crashes, users are sent back to the USS tab, where they are free to access unauthorized applications if they know how to do so. When a transaction crashes, users are free to access unauthorized transactions. Instead, Virtel Web Access memorizes the logon authentication and authorization in the form of the application selection menu that we displayed a few slides ago. When an application crashes, users are sent back to their own application selection menu. Administrators can define a fallback procedure that Virtel will implement when a transaction crashes. The bottom line is that Virtel users are never allowed to roam free inside the host after an application or transaction crash. Another instance of Virtel Web Access keeping the control of access to host assets on the host where it belongs. Here is the application selection menu that Virtel Web Access serves to a user after a successful logon. It reflects the user's authorization level as identified at logon by RACF, AFC2, or Top Secret. The same exact menu is served again to the user after an application or transaction crash. It prevents the user from roaming free after an application or transaction crash. Now let's discuss Web Access Audit Trail. Client-based emulators simply do not provide any Web Access Audit Trail. Virtel Web Access enables administrators to define the Web Access Audit Trail that they want to save. For example, no tracking when retrieving an image, but tracking when using a VTAM relay. This data can be used to feed a non-repudiation process. It can be stored in a VSAM file and/or SMF. By default, SMF record 223. Once again, Virtel Web Access keeps the control of access to host assets on the host where it belongs. The main difference between Virtel Web Access and TN3270 emulators when it comes to security is with the Java client applets, or lack thereof. TN3270 emulators rely on distributed client applets, typically Java client applets. When it comes to security issues, Java is the second most notorious software, right after Flash. Java updates are periodically published to patch Java security exposures. Distributed Java client applets are quite sensitive to these updates. It makes the support of distributed Java client applets particularly cumbersome and costly. If the Java security updates are not applied, the TN3270 clients may be exposed to attacks. With TN3270 emulators, the host security relies on the safe practices and regular Java software updates of thousands of distributed TN3270 emulation users. Who knows who they are and where they are and whether they're applying those Java updates? All it takes is one compromised TN3270 client to expose the host assets. The host can't verify that all TN3270 clients are safe and that none is compromised. In effect, the host has lost control of the access to its own assets. With Virtel Web Access, the web browser is the client. For each new 3270 screen, Virtel generates and serves a new and uncompromised web page, which is rendered inside the web browser's sandbox. Web browser sandboxes are a safer environment than Java client applets. And web browsers are getting safer all the time, thanks to the huge security investments of their publishers, Google, Microsoft, Apple, and Mozilla, for whom security is a growing requirement and a growing differentiator in their competition for market dominance. With Virtel, the security of host assets doesn't rely on hundreds or thousands of distributed clients. The host retains full control of access to its assets. The web browser is the client, and Virtel leverages the security investments made by web browser publishers. Ask yourself, what technology should you rely on to secure the access to your host assets? On the one hand, TN3270 emulators rely on notoriously unsecure Java technology, and for some of them, on the Java plugin that has now been deprecated by Oracle. On the other hand, you have web browsers whose publishers are industry giants that have clearly demonstrated in recent years that security was a top priority by discontinuing the plugins responsible for security exposures, and by sometimes engaging in considerable redevelopment efforts, such as Microsoft, who developed Edge, a brand new web browser, from scratch to replace its existing web browser, Internet Explorer, mostly to improve the web browser security. Talk about a costly investment in security. It's obvious to us that relying on the web browser rather than Java components to secure the access to host assets is a much better choice. Now on to macros. Macros are user-developed productivity improvement tools that work as application extensions. Because of their business value, they should be treated as a business asset. Left in the hand of end users, they can create serious security exposure to host assets. With TN3270 emulators, users develop, manage, and store on their workstations any macro they want. There is typically no inventory of those TN3270 macros, and they do not undergo any security or administration audit. There is always a great deal of redundancy between user-developed macros, and little or no sharing. Some of those macros create very serious security exposure. For example, we've seen logon macros that contain unencrypted rackf user IDs and passwords. We've also seen macros that feed from an Excel spreadsheet to activate thousands of transactions at once. Such macros are very dangerous to the host assets. All it takes is one compromised client device to wreak havoc on the host assets. With those distributed macros, the host has lost control of the access to its own assets. Additionally, despite being a business asset, those macros are owned and managed by their developers, the TN3270 emulation users. The business has no control or ownership over them. With Virtel Web Access, organizations can replicate what they were doing with TN3270 macros, if that's really what they want to do. But Virtel Web Access also enables the administrator to force all user-defined macros to be stored on the host, safe and secure behind the host firewall, where they can be inventoried, audited for security issues, and shared, or not, between users. Administrators can eliminate the duplication and organize the sharing. IT programmers can participate in the development of general-purpose macros. Auditors can ensure that the macros do not cause unwanted security exposures. This productivity tool, application extension, and business asset is back under the control and ownership of the business and its IT department. This is another instance where Virtel Web Access allows keeping the control of access to host assets on the host, where it belongs. What about disconnected clients? With TN3270 emulators, the Java applets and macros are still exposed while the TN3270 clients are disconnected from the host, but still connected to the web. Instead, Virtel Web Access doesn't leave any component exposed to attack while the clients are disconnected from the host. This is another security benefit of using the web browser as client. To complete the end-to-end securing of the web access path, it might be a good idea to protect the 3270 clients from attacks by treating them all, mobile devices and traditional PC workstations, as mobile devices, and managing them with a mobile device management product to restrict the software configuration to operating system, web browser, and whitelisted applications, apply automated software and security updates when the devices connect to the internet, and segregate corporate data, emails, and documents from personal ones. This is quite a departure from today's software-heavy 3270 client workstations, and it may not be for every organization, but it can be done, and it generates tremendous benefits as experienced by our customer, Fraken. So let's review the shockingly novel project of our customer, Fraken. What Fraken did fits perfectly within the scope of this presentation because it embodies the key principles that have been used to design Virtel, its architecture, and its security features. Depending on what side of the fence you're on, and how long you've been in the mainframe industry, you could say that Fraikin has redefined the future of the 3270 client workstation, or that they've reinvented the dumb terminal in the age of the internet. You decide. With 58,000 vehicles in 15 countries, Fraikin manages the largest European commercial vehicles fleet. In 2016, Fraikin decided to get out of the mainframe client workstation business altogether by replacing the 1,500 Windows PC workstations used to access their mainframe applications with minimalist Chrome-based devices from which all applications are accessed in the cloud. This is what Fraikin's new 3270 client workstations look like. The traveling staff got Chromebooks. The office staff got Chromebit dongles that they connected to their monitor, keyboard, and mouse. Chromebit dongles are about the size of a candy bar, and they retail for just $85 in the US. Quite a bargain. Either devices connect to the internet via Wi-Fi. Only Chrome OS, web browser, and whitelisted applications can be installed on those devices. For desktop applications, Fraikin went with G Suite for the cloud, which is Google's version of the Microsoft Office suite, except it's provided as a cloud service. For 3270 applications, Fraikin went with Virtel Web Access. This is why they are our customer. Fraikin manages all those Chrome devices with the Chrome Device Manager. They ensure that only authorized software is installed on the devices. They push automated software and security updates to the devices, and they segregate corporate data, emails, and documents from personal ones. Although this enterprise-wide virtual device infrastructure initiative was initially aimed at reducing costs, and it did drastically, it resulted in the design of an ultra-thin and ultra-secure client workstation, one with greatly reduced and simplified support requirements, and with unparalleled mobility and flexibility. As said earlier, you can look at it as the mainframe client workstation of the future, or a return to the dumb client workstation of the 70s, because it's both. This project embodies 4 of our core security design principles. The web browser is the client. The control of access to host assets is kept on the host where it belongs. Only standard web technology is used outside the host, and it leverages the security investments made by IBM and Google. Once the path from client device to host application has been firmly secured, the last security requirement is user authentication. Are users really who they say they are? User authentication has become more complicated and more critical with web access. Single-factor authentication based on RACF, user ID, and password is no longer sufficient. Multi-factor authentication is highly recommended. It typically includes a combination of something you know, something you have, and something you are. Something you know, for example, your mainframe logon, or an alternate logon, or a response to a secret question. Something you have, for example, a smart card, USB fib, PIV card, client certificate, or SafePass code sent to your personal mobile phone or email. Something you are, for example, your device name, IP address, or your biometrics. Multi-factor authentication typically combines modern authentication technologies such as those listed below. I'm sure that you recognize them, but I'll spare you the alphabet soup. So what is the role of Virtel Web Access with multi-factor authentication? Virtel can coexist and integrate with any IP security technology, including SSO and proxy servers. Custom-developed Virtel scenarios integrate the SSO, host application, RACF, and end user as illustrated in the next slide. This diagram illustrates how Virtel integrates the SSO, RACF, host applications, and end user into a comprehensive and seamless multi-factor user authentication and web access system. First, the end user requests access to some data or screen via a multi-factor authentication system. Virtel is of course not involved in the multi-factor authentication itself. Then, Virtel receives from a server authenticated by its IP address and server certificate a web access request from a user that has already been authenticated by the multi-factor authentication system. Next, Virtel requests a pass ticket from RACF for one-time access to the requested host resource. Next, Virtel uses the pass ticket to get the requested screen or data from the host application. Finally, Virtel sends the requested screen or data directly back to the end user. This is pretty much how most such integrations work. One of the strengths of a system like that is that it doesn't move around any user ID or password. On this final slide, I have listed all the components of our end-to-end web access security. Note that Virtel is solely responsible or a key participant for all but one of the security features. Thank you for watching this video. I hope that you now understand how secure Virtel Web Access is. If you want to know more about Virtel Web Access or other Virtel products, please check our video library. Keep your mainframe front and center with Virtel.